Okay. Okay, then let's start. Does this light stay on, Pete?
I would turn it off. You'll get better contrast on the screen.
Okay, welcome to our weekly weather discussion. We haven't been together since late or early May, and now we'll be together until, again, early May. So it's just one of those things. If you haven't come to this before, some of you haven't, of course, we do this every Friday. We're still not certain of the time. We might be able to rearrange a few of the deck chairs here and move it back to 12:15, which has been its traditional time. Might make it easier for some of you to get here from prior class. But that will be forthcoming in an announcement if we can do it. But what we do is we have an informal discussion of the current weather and then a forecast. Sometimes one person does the whole thing, other times it's split into two. Some of you who are taking 751, I don't know if I see anybody out there right now who is, except Mitchell. You might have an opportunity to give a weather discussion during this semester, but not and for a while, so that you feel comfortable when you get your chance. The elements are up to the person giving the discussion, and it's not a lecture, so it's not going to be something that's a formal lecture, and you don't have to raise your hand to make a point. It's nice to be courteous to the person who spent time getting ready, but you don't have to treat it quite the way you would in a class. But it's a great opportunity to talk about the weather, to integrate, I think, the things that you're learning in a variety of different classes that might have some bearing on weather systems and the analysis of them. So we're hoping that lots of people will contribute as the term goes on to various contributions, various parts of the discussion as we move forward. So Pete has developed this really gorgeous one-week animation. There are times where, especially in the spring, where I come out of my class and I haven't thought about a one-week animation, and I don't want to look at it, and it kind of makes me mad that I have to think about talking about it sometimes. But this is great. It's been a really interesting weather period over the last week. So let's wait till we get back. The only thing is we can't tell it to start again.
Sure you can.
Pete can. I can. So here's the beginning. This is last Friday. And so now we'll animate forward. We're going to see, I think Hurricane Idalia gets into this picture, right? Or were we already past that by that time?
That's it.
Oh, it was late August. Okay, so it's out of the picture. Okay, so all the hurricane activity, the recent Atlantic hurricane activity was gone. We're going to see really scattered showers that missed us. We got a couple of heavy downpours over the mid part of this week, but it wasn't really a serious hit of high intensity precipitation. And then here comes Hurricane Lee, which is a focus of both the current weather discussion this morning as well as the forecast that Patrick will do. And then behind it is Hurricane Margot. I think it's a hurricane now. Might be just a tropical storm still. And then we'll see also, perhaps on this image, but it might be off the image a little bit, Hurricane Jova. And there it is, coming in the eastern Pacific. And it looks really nice here on, what is it? This is the 7th, a couple of days ago. And it has since degraded in its presentation a little bit. So has Lee this morning, but I'll get to that when we talk about it in a little bit of detail. So there's always something going on in the tropics in September and October. The tropics don't stay in the tropics, though. That's what makes it so interesting, is that they migrate to the higher latitudes and they do some damage occasionally. And not just damage to structures and properties, but also damage to predictability and damage to the structure of the circulation at high latitudes. That is still, as we'll see, struggling to get itself organized. It's not cold season yet. And it really, you can really see that when you look at the weather maps at upper levels. And this summer we had some excitement in my research group because Libby Orr is working on trying to find where the tropopause level jets are in the warm season. And I don't want to disclose any of the really grave secrets there, but there's some really interesting stuff that's coming, I can promise you that. And I think it's going to change the way that we have to think about this interaction in the shoulder seasons of the tropics and the extratropics, because we'll have a better handle on what's actually true about the extratropics in the end of the warm season anyway. And that's going to be quite interesting. Okay, so let's go from this, Pete, to a more parochial in time view. So we'll look just at the U.S. Current satellite image instead of the whole week. That's the thing that I sometimes don't like about it, because I don't have something to say about the whole week, but I can say something about the last day. So let's, oh, and of course Pete's biased, color vision. And it's okay, and there's Hurricane Lee. And if you've been watching the hurricane, you'll notice that the eye has got a little obscured this morning. And I guess there was a report that we'll see in the NHC discussion of kind of moderate southwesterly shear, 15 to 20 knots in the 200 to 900 millibar layer. And that was what they have said has accounted for a little bit of the loss of the eye. And I guess consistent with that is the southwest section of the storm is not as it's not really symmetric. It's kind of carved out here, and it's a little bit inflated to the north and east. So that's maybe what's going on. The expectation for Lee is, though, that it'll shed any detrimental effects of that shear and just continue to be a Category 5 hurricane, chugging, thankfully, poleward of the Lesser Antilles and Puerto Rico, as well as the Dominican Republic and Haiti. It's going to move out like this and then make a curve up toward maritime Canada during the coming week. So it's going to be an interesting storm to watch on a lot of reasons. And yet, it'll spare a lot of places that take a lot of hits from these storms, a direct hit from this one, it looks like, and I hope that will remain the case. And here's Jova, I think today 95 knot maximum winds as it kind of gets a little bit weaker. I should have mentioned with Lee, maximum winds have been about 145 knots, and they have a forecast in the next half a day to get up to 155. So that's a major Category 5 hurricane, an absolutely beastly storm. And what we're seeing here is just the remnants of a cutoff low that was non-tropical. And I had a mistaken impression about that yesterday in Weather Watch in our discussion, in 452. That is non-tropical. That's just this kind of persistent cutoff low that was on the southern side of a jet feature, weak jet feature in the extratropical circulation. That jet feature is now responsible for producing the cloudiness, and I'll say how, across northeastern Canada in the current depiction. And aside from that, it looks like there's smoke in a lot of different places, if I'm reading that right. That's not surprising. Low clouds have hung around over the southern part of our own state all morning long. I guess they're kind of getting a little bit thinner so we can see a little bit of the sun through them. But there does not seem to be any substantially well-organized weather system to our west, so I don't think we have any threat of precipitation. While we're talking about precipitation, I just want to remind you about the summer we just had. So we had a smoky June. If you were here in June, it was almost every day was hazy, and really hazy on some days. So we had a really smoky June. 4 days got to 90 or above for high temperatures, and there were 4 at 89. So I kind of count them in the back of my mind because who knows, maybe we weren't exactly right about the temperature, right? So there's 4 days over 90. We were 0.8 degrees Fahrenheit above normal for the whole month, which is just about normal. That's not anything big. But the big thing in June was we were 4.14 inches below normal in precipitation. And for the first time since I've lived here, everybody's grass at the end of June looked like August. It was amazing how brown everything was. It just didn't rain. Then July was kind of rainy. We ended up with 1.7 above normal for precipitation, largely because of 2 rainy days. And so it was a weird month again. On the 12th, I think we had 1.6, and on the 28th, we had something close to that again. And that was almost half of the total for the month. And July was also 4 days at 90 or above, and we were about a half degree above normal. So again, a normal temperature month. And then August, we had 3 days above 90 degrees, 0 both in July and August at 89, so there are no close calls. So that gave us 11 days at or above 90 for the summer. And then we had 2 in early September, so it's 13 total, and that's about exactly Madison's average, as it turns out. So despite all of what seemed at times to be, oh, this is excruciating humidity or excruciating heat, we didn't have anything abnormal this summer, except we ended up something like 4 inches below normal for total precipitation over the 3 months, which I think will have a bearing on crop yields and various other things. So we ended up about 0.8 degrees above normal.
We did have an 81 dew point though that one day. I think it was in July.
That is true.
Which ties, I think, our record.
Yeah, it ties the record for me. I don't know if it's a record for the city, but it might be. But that ties my all-time record, and that was. And we didn't think that was happening. Remember that morning, Patrick? I said, "Oh, it's only 78. I'm not going to get my record in 81." So yeah, it was not long ago, a couple weeks ago.
Was it mid-August?
Yeah, maybe. Yeah, something like that. In the early 20s or late teens of August, yeah, something like that. So that was pretty exceptional, but very short-lived. It was only that morning. In fact, 7 a.m., right? It was 81, and then by the time we got to work, it was 78. So the dew point was already dropping. So
which is much more comfortable than here.
Yeah. It's in a whole other category. So thankfully, that's the way it went. So that's a recap of the summer. The summer was just about normal with episodes of abnormality, and isn't that a description of life? I mean, that's how it goes, isn't it? Let's take a look at the current satellite movie. We already did that across the U.S., didn't we? I want to look at a couple of the different wavelengths, though. Let's look at the infrared. No, I like the grayscale infrared, the old style, Pete. I'm going real
Old
old
school.
school on you on this, yes. So get out of this, go back to our webpage. Okay, that'll do. So here's the infrared, and I guess it's not really particularly illustrative today, except though you can see the clouds are low clouds over us. And if you look outside, you can tell that. And then these ones that are radiating at colder temperatures are a lot brighter in the white. It was more obvious yesterday in a different depiction. And it was really relevant because we were trying to talk about, let's try and diagnose where these clouds are coming from. Step one is to understand where they are in the atmosphere. You got to know that first. Are they high or are they low clouds? So these are low clouds over us. And yesterday's infrared showed this band across southeastern Canada being considerably better organized and a little bit more intense in its white. So there were thicker clouds yesterday there than there are today. Okay, let's also take a look now at the continental radar summary. And so I'm not sure why everybody's got their power turned up from, south of the Great Lakes all the way down to the Gulf of Mexico. This is the second day in a row we see all of this extra, blue that's not really doing anything, but the precipitation is scattered and not widespread. Something flowing through Arkansas into northern Louisiana, the front edge of it fairly strongly convective. A second day in a row of some convective showers in an odd orientation over the peninsula of Florida. And then yesterday, it was heavy rain along much of the eastern seaboard, here and there spotty. May even regenerate today, I think, but it's not going on right now. And then over us, you'll see why, certainly no precipitation over us, and then much of the western states, with the exception of parts of Montana, also enjoying a fine day in early September. So it's a pretty good day across the country, with a couple of different places where it might be a little bit more exciting than local residents might like.
So John, two
Yeah.
things. First of all, there is a little precipitation out there. It was drizzling over on the east side this morning.
It was here on campus too.
Yeah, a little bit of precipitation. You maybe can pick it up a little bit on there. And then in terms of the blue splotchiness all over the place, I don't think they actually turn the power up on the radar. I think it's just humid. But it's either,
I think they have a sensitivity dial that they can turn up on that, but I don't know if that's it.
yeah, I'm not positive about
Okay,
that.
I might be wrong about that. Yeah, it is humid, and that leads me to wanting to look at our surface observations on the traditional large map. Where is the air really soupy? Not here, thankfully, that's the case. I'm glad about that. But we'll see. Okay, so let's start in Madison. Yeah, a little bit of light drizzle. What time is this, Pete? Is this 14Z or something?
Amateur hour here. This is
17Z. Okay, so 17Z, about 11 a.m., so in the last hour.
Uh-huh.
Well, what happened?
I just
Suddenly we're on Vancouver
yeah,
Island.
I know. It's been a while since I've done this movie.
No, that's perfectly correct, Pete. And plus you're handicapped because this thing isn't really behaving the way that it does on your own screen.
Yeah.
Little drizzle, 62 over 56, oh, that's a magical number. 50-degree and lower dew points in the northern part of the state, and where it's clear, the dew points remain in the low 50s, so that's nice. When the clouds clear out, we have no threat of an increase in the dew point, just a little bit of an increase in the temperature, and that's the whole essence of autumn, right? The best month of the year is coming, September 15th, October 15th is coming, and that's what it's going to be like every day. So beautiful conditions for us. Look at the dew points I saw earlier this morning. I saw an earlier map, they're still pretty good. 86 over 74 in the hub of the universe, Boston, Mass. And Providence, 85 over 70. That's what they call it, the hub. That's why. Right, Carolyn knows. It's the hub. It's 85 over 75 dew point in Providence, and then a 74 dew point in Hartford. That's brutal. Okay, that's brutal at any time of the year in New England. But for early September, the second weekend in September, nobody expects this. It's like the Spanish Inquisition. Nobody expects it. And then the dew points in the Chesapeake Bay are in the mid-70s as well. Philadelphia, 70. That's not comfortable. Nobody likes it. And we had it just before our change in the second part of this week. So it's nice to see it go off.
There's a 70 dew point in upstate Maine, way up in the top.
Yeah, look at that. That is Houghton, Maine, 70-degree dew point. That's unreal.
Wow.
Nothing but pine trees surrounding this for hundreds of miles. And it's beautiful, but that's nonetheless the case. 70 at Portland with the wind off the ocean, 70-degree dew point, 79 Fahrenheit. It's great. If you live there, not for me. Okay, that's really all I wanted to show Pete was from that. You can't find higher dew points, and you can investigate on your own. You can't find higher dew points anywhere in the country today than in New England, which is very unusual. You don't usually get to make that statement. Okay, can we take a look at, what did I have next on my list? Oh, let's go to the National Hurricane Center and think a little bit about Hurricane Lee. No, not that. Upper level charts first. That's what I got in mind. The super beats. Eponymous super beats. So here's 12Z this morning, and what a transformation goes on from early September until actually maybe end of October. The geopotential heights that are in black here are drawn every 60 meters above sea level, and the gradient, so the spacing of them on a horizontal map just intensifies week to week. The whole organization of the structure looks better and better as time goes on. Right now, this is about the most dilapidated 500 millibar map over North America that you'll ever see. It is worse in July and August, but you don't see them because we don't have the discussion. But at this time of year, this is dilapidated. And Libby has given us new insights about some aspects of the dilapidation. Look at how tight the gradient is over the southern part of the Labrador Sea. It's tight just south of the Aleutians, and then it's trough over the Gulf of Alaska. That's the only couple of places on this whole map which occupies, I don't know, 40 or 50% of the Western Hemisphere, where there's any tightness to the gradient, which means high wind speeds. And we'll see when we go to 300 millibars, that's the only place the jet resides. So there's no jet to the south. And that's why the hurricanes are flourishing. There's Jova. And look at this giant anticyclone over the southwestern United States, actually centered over the country of Mexico. And that's been a semi-permanent feature for the last 10 or so days. And it's slowly actually retrograding to the west, as it turns out. Puts us in weak, almost undiscernible northerly flow with no temperature contrast. It's minus 12 at 500 millibars at International Falls, minus 10 at Green Bay, and it's minus 8 at Lincoln, and minus 11 near Dubuque. So we're talking about, not Dubuque, Moline. So we're talking about almost no temperature advection at all with light 500 millibar winds. The same is true at other levels. We'll see 850 inches. There's our cutoff disturbance that we saw reflected in the clouds just off of Newfoundland. And you don't see Hurricane Lee too far off to the east. So all of the active weather is at high latitude. This is a winter-looking trough. This is a winter-looking jet streak. We'll see when we go further on. This is kind of a winter-looking trough here in the central part of Manitoba near Lake Winnipeg. But everything south of Lake Winnipeg is the tropics, including us. So that's pretty interesting. And it's commonly the case in the end of the summer, end of the warm season. Let's take a look at 300 millibars next, Pete, just to emphasize this thing about the jets. Again, later on in the year, you're going to see these ice attack maxima. This is 122 knot ice attack maxima. This one's 150 something, 142 on the west side of the upper trough over the Gulf of Alaska. These things are residing only at high latitude right now. And if you looked at the whole hemisphere, you'd see the same thing's true in the rest of the western and all of the eastern hemisphere. The only little bit of a jet lit feature is at the base of the trough over Lake Winnipeg. Everywhere else, there's no jet. Just for the fun of it, traditionally the polar jet resides around 300 millibars. Let's go higher to 200 and see if we can see any evidence of the so-called subtropical jet. Nope. In fact, the jet maxima was at 300 millibars. It weakens with height over the southern Labrador Sea, and it maybe is about the same, or maybe intensifies a little bit with height at the latitude of the Aleutian Islands. So the subtropical jet core is over the Aleutian Islands in the western part of North America. And then you've got this weak 80-ish meter per second feature that's coming in across central California at 200 millibars. Absolutely nothing in the real tropics. So the tropics move at least, you could say, to the latitude of central Illinois at this time of year, at least, and arguably to southern Canada. And that is really interesting because that tells you a lot about the kind of weather systems that are even allowable during the warm season and where they reside. And that matters a lot for ice and various other things at high latitude. So we have to understand this better, and we're in the process of doing that. Let's get one last upper level chart, Pete, 850 millibars. That'll give us an idea of what sort of temperature structure we have closer to the ground and maybe some advective parameters as well. So 10 degrees at Green Bay, 14 near Minneapolis, 10 at International Falls, and then around 10 in Illinois and Iowa. So again, uniform temperatures over the region and very light northerly winds in almost all those locations. There's a northerly component anyway. But there's no strong cold advection. So we're at the temperature we're going to stay. We're not going to get cold. And that's what that indicates to me. And also not saturated, so there's dew point depressions in the, modestly high numbers, 9, 7, down further to the south, 2, 23 at Minneapolis. So we saw that's where it's clear, and so the air is drier there. Contrast that with Portland, Maine, 17 degrees at 8:50, dew point of 14 at a mile above sea level. That's a lot of moisture, a mile from the ground to that particular point in the atmosphere. Same down here in, near Long Island, 16-degree dew point at 8:50. That is 15-degree dew point on the plains of Abraham, right up there near Quebec City. So that's brutal. Okay. Now let's go to NHC and just say a little bit about Lee. I'm going to leave most of that to Patrick in the forecast discussion. Oh, no, Pete, sorry. I'm new. I'm remembering how to do this too. Let's go to the West Coast satellite image first, because we didn't say anything about that. And I had that. I think I had that. Maybe I didn't have it loaded up, but we can get it quickly. Yeah. Okay. So this is an interesting satellite movie. Of course, there's Hurricane Joe, but that's interesting. ITCZ is lit up across much of the Pacific with a gap in a few of the longitudes. Here's Hawaii. And then here's the thing that's really interesting to me. You can see this big anticyclone in the clouds. Watch it rotate. That's a big anticyclonic rotation at about the date line. So you don't often see that. It's nicely described in the clouds on the periphery. That's not often the case. And then on the, so this is a ridge, and then there's a trough downstream of it, and in the trough side of it, cold advection prevails, and you can see that manifest in the stratocumulus that's developing here south of the Aleutian Islands. And then downstream of the trough, which is, its axis is right there, is the development of this pretty weak but discernible cyclone crashing into the British Columbia, Alaska, Yukon-Alaska border, and it has a cold front trailing to the south. So that's kind of a nice high latitude wave train. This latitude here is about 42 degrees or something. So that's a pretty high latitude wave train and a really discernible ridge. And one might get the impression, without knowing more, that this is the extent of the wave train. That's not true. We're getting cut off in the western part of the image. So let's go to Alicia Bentley's maps to show that. So this is about where we got cut off. So there's the big ridge in the thickness field. And then look at downstream, cyclone, anticyclone, cyclone. There's a whole large collection of waves upstream that are emanating from Siberia, really. I don't know more than that. I'm just telling you what I see here. Here's 540 thickness in blue, so cold air is coming in behind this last of the waves in the train. But there's 1 wave, 2 waves, 3 waves, and intervening ridges. And we only saw the big ridge with its clear circulation anticyclonic around the western edge of the Aleutians in the satellite image. So it's always interesting to go as far upstream as you can and see what is the lineage of some of those disturbances that might otherwise catch your eye on the satellite. And this is a really good example of that. Right off the bat, first discussion of the year. But look at the average latitude of that wave train. It's well over 40 degrees. It's like 50 degrees. Again, testifying to the fact that anything that looks extratropical is just pushed way to the north at this time of the year. It's rare that you get any intrusions. And it's, even when they're active, they don't intrude into the real mid-latitudes, 35 to 45 degrees, 35 to 50 degrees. Okay, so that's kind of interesting. And a really intense jet streak at 250 millibars across the eastern part of the Aleutian Island chain, and that's helping develop this weak storm for sure, for reasons that we'll gradually describe as this semester goes on. And that's one last thing, is this is a fairly unusual jet depiction compared to what you see in the wintertime, where it's a lot more zonally oriented, maybe deflected poleward, maybe deflected equatorward, but it's got a zonal orientation, not such a segmented wavy orientation. Again, probably an artifact of the nature of the circulation in the summertime, which we're hoping to unravel a little bit and learn more about. Okay, now, Pete, we can go to NHC. And we'll hit Lee. We'll leave Margot alone. That's going to be for next week, I suspect. So let's go to the messages, not messages, discussion. Yeah, thanks. This is from 11 a.m. So as it says that the satellite presentation degraded somewhat this morning. The eye got a little smaller and filled with clouds. And they mentioned maybe a result of shear from the southwest that might have gotten in the way of development or hindered it for a while. No secondary eye walls that they can tell. That also can sometimes give intensity fluctuations. They got a hurricane aircraft in there that's got some really interesting measurements, and it leads them to an estimate of winds in the 130 to 140 knot range at the ground. right now, or 11 a.m. And pressure's gone up to 942. I confess I don't know what the lowest pressure was in the history of this. Maybe somebody does. But I don't know that it was lower than that, but it clearly implies that it was. And they're all estimates. And so they're giving the initial intensity at 135. That's a strong category, or a category 5 hurricane. And it's moving west-northwestward. It's suggested to do that for a couple of days and continue to wreak havoc. And here's some of the forecast information. So tonight at 6 p.m., it's forecast to intensify, maybe gust to 155, staying at 135 sustained, which it's at now. And that might be the peak of its intensity over at least the next several days. As it moves 5 days forward, it's moving further and further to the west and, doing some damage to the open ocean. Might be interesting to see some pictures of sea surface temperatures if we can do that live. I know Myra showed me a place where you can do that one time, maybe Hannah did too. And in the wake of such a strong storm, you're just kicking up cold water. You'll have a little cold spot right behind it, like a snail's trail. And it doesn't take long to get that processed, but you can see it. Luckily, it looks like this storm is not going to be affecting any of the Lesser Antilles, neither Puerto Rico, and it may have an impact on maritime Canada, which was not uncommon last year. What was it?
Fiona.
Fiona was a disaster in Nova Scotia last year, and so there's a threat of that coming up. So the last thing I want to do is let's take a look at Lee, and we'll do it in tropical tidbits, Pete. I think I pulled that up, and maybe I didn't. I thought I did. Sorry. And let's go to the North American view when we get to the models, so we'll go there first. And then regions, no, North Atlantic, sorry. And that's right there. Okay, so this is current, just about exactly current. Let's draw a cross-section right through Lee. The forecast, it's a 6-hour forecast, and it says the pressure is 975. That's not what the estimate is. Yeah, right through the middle, perfect, okay? And then let's do potential vorticity. So we're trying to get an idea of what the PV structure of a mature Category 5 tropical cyclone is, and that's it. So it's a little cigar of high PV. Now, the other important stuff that you might just blow off, because that's so eye-catching, is that it's surrounded, it's got a skirt at the tropopause level of low PV. These places are below 0, okay? So this is exhaust from the convection in the eye wall, and there's low PV there. And my contention, I always used to ask this of Greg, and he couldn't give me a straight answer, and I think I was right, and he probably acknowledged that, but he wanted to say something else instead of just answering my question. But is this a measure of the scale of a tropical cyclone? How far do you have to go out from the core before you stop seeing the negative PV in the outflow? Because I imagine that it just puts this big anticyclonic PV disk at the top of the troposphere, and there has to be a lateral edge to that, and I think we're seeing that right here. So when somebody says, what's the scale of this thing? It's easy to say, good thing Morgan's on here, because I always say this to him, tropical cyclones are so small scale, they don't matter. I mean, come on, they're intense, but only in your neighborhood. But they're intense and they have an impact on this scale. That's the synoptic scale. And so they do have a synoptic scale impact. He's not listening in Washington, I'm sure of that, but maybe I'll hear from him. Anyway, that's one of the interesting parameters that I wish I knew more about is how do you actually measure the disk size of the low PV at the top of the troposphere in the vicinity of one of these tropical cyclones? And that's the scale that matters. This is 50 and 60 and 70 meter per second winds, okay, sitting down there. And then the dashed ones that mean they're coming, I think, out of the page. These are going into the page, so cyclonic rotation, or the other way around. Okay, let's go ahead 24 hours, Pete, following Lee, and see what the structure looks like. Oh, it's okay, we'll just go forward. So to 18Z on Saturday, keep going, right there. Let's do the same thing again. A little smaller scale, eh, Pete?
Well, it makes it look
It'll
more
work,
impressive.
yeah, it does. Watch this. Okay, intense. Look at the scale at upper levels. It seems like it's bigger, that this thing gets more impressive on its scale at the tropopause level. But look at these winds. That's the 60 meter per second ice attack, so I can see two more, 70 and 80. And I even see a 90 right there, 90 meter per second. That's like 180 mile per hour winds. I'm not sure that's actually going to happen, but nonetheless, that gives rise to this cigar-shaped PV anomaly that absolutely stands out from everything else in the tropics. And then these are the potential temperature isotopes in green. So there's the warm core as well, all the way to the ground, but especially intense in the middle and upper troposphere. That's really intense warm core disturbance. And let's go one more day. Let's follow it.
What's interesting here too, because it's pressure as a vertical coordinate.
Oh, yeah.
You actually see the low pressure with the ground. goes
Yeah,
up.
because you know you're over the ocean. There's no real elevation. So that is 950 is this line, and the forecasted pressure is just a little bit higher than 950. Pretty incredible. And that's where they're small scale. I mean, that's where the pressure perturbation is small, but not here. Okay, let's go one more day. So we'll go to 18Z on Sunday. Okay, and then we'll do it one more time. Thank you, Pete. And see what this has. Yeah, look at that. So same basic structure, and we're seeing 40, 50, 60, 70, 80, 90 again, same exact thing. And look at how intense, how little vertical shear there is, but how intense the gradient and horizontal the wind speed is. And then the incredible warm anomaly from about 400 to 200 millibars. And it's notable all the way down to the ground, as I mentioned before, and the pressure is at about 957 or something like that. So this is a really intense structure, and it maintains it for, this is now 2 full days, and we're seeing fluctuations in the scale at the tropopause level. And I think that's the scale that matters for affecting other features in remotely. Okay, so remote impacts on forecasting or predictability come from this, not this. That's my contention. So that's all I have for the current weather. So Patrick's generously donated time to do the forecast, so I'm going to turn it over to him. Pete, thank you for expert driving.
Perfect, thank you. So I sent an email without my link, so I have to pull that up. But what I'm going to talk about is first talk about the drought, as was started by Professor Martin. Then I'm going to get into our week. Will we see rain? Will other places in the United States see rain? And then we'll look at Hurricane Lee as it interacts with something that will affect us and maybe make this a notable event. For Nova Scotia, which got hit by Hurricane Fiona almost to the day 1 year ago, and it was the costliest storm on record for Canada. We might see almost the exact same thing. So could we go, I actually did this backwards. So the last link is what I would start with. Perfect. And could we go to cumulative precipitation? So, as Professor Martin pointed out, it's been dry since classes ended. We are currently in a stretch that hasn't received any measurable rain since, I'd say, in between middle August, and this trend looks like it might continue to the end of the water year. And so this would put us, each of these lines are 2 inches below normal. So we'd have 2, 4, 6, 8, 9 inches below normal for our precipitation for the water year. And it's been dry this summer, and so we can look at, is this going to continue? It will for sure continue, I can tell you, to the end of September, but we'll look at my next link here, which is the drought monitor, and we can see if this trend will continue here. So first, we'll highlight the Midwest here. No surprise, we are in a drought. Dane County is right here, Madison's about in the middle of it. So we're currently in severe drought. We got into extreme drought over the summer. Due to those 2 days of rain in August and late July, we got out of extreme drought. If we click on Wisconsin specifically here, get a little closer. These regions of exceptional drought, and then there's one up way at the top of the state. The first time this has ever happened in Wisconsin since the drought monitor existed in the year 2000. And this one is a little close to home. I could see in the next week, if we don't see any rain, for the next, till the end of September, this region will definitely expand. We might even be in this exceptional drought category. Definitely not out of the picture based on what I'll show and what the trend is looking like. But this is unprecedented for Wisconsin, and it looks like these regions will expand. And so we might be seeing drought conditions for a while, lasting well into fall and maybe even into winter here. And so we can go to conditions and outlooks, and we'll go to outlooks. And I'll focus on this map first. This is a look at the month of September, released August 31st. The color shading will tell you what they are expecting. So currently, anything in this brown, grayish brown color, this is where there's currently drought, as listed by the Drought Center. anywhere there's this yellow shading, they expect drought to develop. So this is a bad signal for the entire middle of the country, especially our region. We are currently in a drought, they expect it to persist. There is not much of any sign that a drought may remain or improve in this like lighter grayish green. I'm colorblind, so I don't know exactly what color this is, but this color right here, the only real region is in Louisiana. Everywhere else, drought is either expected to persist or get developed. And this is just persist. They don't exactly say if it's going to worsen or stay the same, but this is a very telling sign of what we've seen throughout the whole summer, what we'll see in September here. And so if we could scroll up on this side, we'll look at seasonal now, and we can click off this first tab. So now this is a look at September through November.
Looks the same, doesn't it?
This is a different map, but it looks the same, exactly right. We're expecting to see drought at least until the end of November. So again, bad sign. We can look at maybe why in the next week we might not see rain, but they're expecting us to stay dry as we have throughout the entire summer. And places in the middle of the country where there's a lot of harvesting going on this time of year, it'll be interesting to see how this impacts the crops. It's definitely doing numbers on crops. So it'd be interesting to see how that affects like our prices at the grocery store or how much this impacts the economy and stuff like that. So drought, first thing I want to cover. We are in a drought expected to persist most likely through the end of November here. So next, this will lead me into my next link. And so this is a map of the current watches, warnings, advisories of the United States. Not looking like much is happening. There's smoke outlooks for Nebraska, for smokes from wildfire. We have a small region of heat advisories, excessive heat advisories. They've actually canceled school in the Northeast because a lot of these schoolhouses don't have AC. They were built in the 1800s. So kids are, the first week of school, already out of school because it's so hot. This has been a picture the entire summer, I would say. Phoenix region, Texas, and excessive heat warnings. They cannot shake this heat. It's 110 plus every single day for 3 months. I could not do that. I do not wish anyone to do that, but they are having to live through that right now. There's a few severe thunderstorm warnings, it looks like in Louisiana and maybe some off the coast of Florida, but relatively quiet, I would say. And we'll see this map as we go on in the semester. Will be full of different colors of warnings and watches and everything like that. And so if we could scroll down to the outlook here, current outlook maps. This is one thing I like to do for my forecast is look at the QPF, the quantitative precipitation forecast. So any precipitation, rain, snow, sleet, can be melted into liquid, and they forecast the liquid amount that is going to fall. So first I want to go to the day 1 through 7. I'll give you the punchline first. So this is a look at 1 week of precipitation forecast by National Weather Service. We can see sort of 3 main regions here that catch my eye. First, South Central Plains, quite a bit of rain for them. We saw there were drought conditions and drought expected to continue, so this is a good sign, definitely, that there's, let's see, between 2, maybe 4 inches of rain all over the South Central Plains. The Northeast, big bullseye of rain here, maybe upwards of 5 to 7 inches of rain over a week in states, Maine, New Hampshire, Vermont, New York. This will probably cause a lot of mess for, there's a lot of people that live up here, especially New York region and Boston, so a lot of commuting issues. And then we are seeing Hurricane Lee beginning to move and make its way closer to the United States and maybe Canada, and that's what this bullseye is right here. You'll notice us, I mean maybe 25/100ths to 50/100ths of an inch of rain, but this is not a good signal if you want to bust a drought. And a large portion of the region around us will not see any rain that is going to do anything for any of the crops. It'll just make the topsoil wet, and that's it, if we see any rain specifically. So now I'll go through, we could go to day 1. Now let's step by day. we can see the northeast is rainy. We'll take a look at why. There's that feature that was moving from Arkansas into Louisiana. That's probably what this is, picking up on the forecast. And then isolated small rain chance in Montana and the Dakotas here. And we'll watch this specifically. So we'll go to day 2. Now we see that feature that was in Montana, the Dakotas, beginning to move towards the south, sort of like a anticyclonic rotation around the ridge that is sitting over the southwest. So that's some indication that this ridge might not be moving. We see the northeast, still rainy, from Maine all the way to the Key West of Florida, so it's a large area of just scattered rain. We'll go to day 3. We'll see this feature again, moving around the ridge. Now it's producing heavier rain into Kansas, Nebraska, Oklahoma. Again, the northeast, still rainy. We'll go to day 4. You can see this feature is now making its way into Texas and Oklahoma. Maybe there's some rain for us. We can take a look at this. This is Tuesday into Wednesday. So we'll see what might be causing this feature, but the northeast, again, scattered rain showers. Go to day 5. Now we might see some semblance of a counterclockwise rotation around of this rain. So maybe there's a low pressure system that formed here that we can take a look at. But again, northeast is rainy. Yeah.
That's a gift to the insurance companies, because that's one of the factors that keeps Lee out to sea.
Yes.
I'm guessing.
For the United States, I'll say.
Yes.
Yeah. And then maybe some relief. Maybe this ridge that was over the southwest moved out of the way. So that's a good sign. We'll go to day 6. Now we see maybe this has become a more organized system. Here's Hurricane Lee beginning to make its way towards the United States and maritime Canada. And day 7 finally, just close it out. Now we see Lee in the track that's forecast. The northeast begins to dry out before being impacted by potentially Lee again. South central United States receiving rain, but our region through this whole time, I didn't point it out, relatively dry. So look at upper level maps here, and we'll see what are features that we can pick out. Why was there a feature that moved counterclockwise, completely missed us? What was this storm that seemed to appear and move off into the northeast? And then we'll look at how it might interact with Lee here. So my next Lee. This might require some driving. So we can exit out of this. Perfect. So I originally was going to show 500 millibar maps and service maps side by side, so you could see what I was talking about in real time and we could compare the two. Then I found this website, which is Polar Weather. It's Tomer Berg from Oklahoma. You can do this in a model sense and overlay the two. So this will give a good look at what I was talking about and what I'll want to feature here. So this is a good look. Let's go up here and click Overlays. So now we're overlaying on top of this just standard surface level map, and we'll go upper level and geopotential height and 500 hectopascal geopotential height. Perfect. Okay. And if we could scroll up just so I can see the time at the very top. Perfect. Okay. So this is a look at the GFS roughly this morning. Guess what was happening? So we have a low pressure center moving. That move gave us maybe some of this scattered rain showers. We have that high associated with the big ridge sitting over the southwest, but largely, as Professor Martin pointed out, discombobulated. We have our 2 hurricanes here. So let's step forward just a couple clicks. I think it goes slow. And I think you can use the keys if needed. Let's go, keep going. Let's go 2 more. So now we're looking at tonight. We can see largely the same picture. We have this ridge is still sitting over the southwest. We have a trough that will persist and is sitting over the eastern side of the United States, creating upper level divergence, ascent, and that's most likely what is this scattered precipitation that we'll continue to see, and I'll show as we go on. But this trough will stick out, and this ridge will essentially not move for a couple days, and I'll show that. If we could just click forward a couple times. goes slow at first. Let's go 2 more. There we go. Let's go 2 more just to make it 24 hours. So now, this is tomorrow around 7 p.m. We see trough and a ridge in the contours, the black contours. Associated with the trough, maybe a low pressure system develops, but scattered rain. Associated with the ridge, lack of rain. We're kind of in this limbo in between where we don't really see any real precipitation chances, any real systems moving through our area. We're sort of in between 2 big features. So we'll keep going here. And we'll go right there, that's good. So now we see, we still have some sort of ridge. Maybe there's a little shortwave feature moving over the northern plains and associated with this big trough in Canada. Our trough sitting over the eastern United States is still sitting there. It has slightly moved to the east, and so has the precipitation chances. And we noticed that in the QPF, they were more focused on the northeast rather than the entire eastern seaboard.
I think dynamically there you've got, you know, the dashed lines either in blue or red are 1,500 thickness, so
Right.
they're a proxy for the isotherm picture in the whole lower troposphere. So there's confluence. It's light, but it's discernible.
Yes.
And that confluence, the axis of the strongest confluence is precisely the axis of the heaviest precipitation in the QPF. And that was true at the prior time, even when it looked less high profile. And I'd say the same thing is true from Wyoming down into Kansas. You know, where you have that almost superposition of the trough that you mentioned and the dying ridge. That presents a local confluence zone from northwest Wyoming all the way into Dodge City, and that's where that little bit of precipitation is coming from, because again, it's confluent photogenetic activity there, I think.
Yeah, definitely. Definitely great point. And they're especially not tied to any surface level feature
Yeah, that's right.
of note. So that is most likely what is creating these precipitation chances.
And that's the
Definitely.
cool thing about confluence, is it's often neglected as a precipitation producer because it doesn't come along with cyclogenesis. You don't see cyclones developing in regions of confluence. They
Right.
don't. They get shredded.
Right.
But it can still rain.
Yeah.
And that's what's going to happen
For
in the
sure.
Northeast.
I mean, upwards of 7 inches.
Yeah.
Not just because of this confluence, but definitely a function of some confluence here.
Yeah.
So let's step forward now, a couple clicks again. We'll notice here's this trough that might bring us rain. I believe this is Sunday. Could scroll up. Yeah, so this is early Monday morning here. We might see rain out of this passing trough. Again, there's confluence. It's weak,
It is weak, but you
but
can
it's
see
still
it.
there. Yeah. And then this precipitation feature that we noticed was moving around the ridge is slowly skirting its way down into the central plains. But you can notice this ridge is has collapsed almost. It's now a flat feature in the 500 millibar heights. And so with this collapse of the ridge, this trough moving in, let's see what happens if we go forward a couple more clicks.
Or another way to look at it too is that the ridge has migrated poleward. I mean, it's
Yeah.
over western Canada now, and it was over the western U.S. before. I don't remember if it had that extension that far north. It might
did.
have.
It's almost like, oh, I guess it did, yeah.
Yeah, so they're not the same feature, but that's
Right.
at the same longitude band. It's shifted poleward. It's really interesting.
That's right. And this shift, it will amplify this trough. And if we keep going here, we can just keep clicking. You'll notice this trough feature kind of sits. If we keep going, something begins to happen where we have a trough, and here's Hurricane Lee. Let's keep going. The two begin to interact. And this is where it becomes interesting if Hurricane Lee is going to hit the United States. It'll most likely hit somewhere in this box I'm drawing from New York to Newfoundland. Somewhere in here is going to get hit by Hurricane Lee. It looks apparent. I will not heed the warnings of everyone saying don't look in the future, we don't know where it's going. This signal has appeared for a couple days now where you will have a trough sitting over the Great Lakes which will steer Lee towards Maine, maybe Nova Scotia. If we keep clicking, we'll just go to the very end. We can see this has Hurricane Lee becoming extratropical, beginning some semblance of fronts potentially, but definitely interacting with the trough, hitting, it looks like right east of Maine.
Yeah, New
here.
Brunswick, Canada.
New Brunswick. Nova Scotia is where Hurricane Fiona hit, which is right there.
Whoa.
exactly a year ago. So this looks like almost the same picture. And in fact, if we could step back, Pete, please, on this look, step back, I'll just tell you when to stop.
And then, oh, just go back to time.
Yeah, just back in time. Right there, one more forward. Perfect. Then can we pull up my next link I have? This is an archived look at 500 hectopascal. Here's Hurricane Fiona sitting off of Virginia, North Carolina. Here's a trough sitting over the eastern United States. Let's go back to what I just had. That's almost the same exact
Yeah.
picture.
Oh, boy.
So
That's an
this looks like
archetype.
a highly impactful event. Like I said at the beginning, Hurricane Fiona was the third to ever hit Canada, the third tropical system ever. We might be looking at the fourth just a year later.
Yeah, amazing.
Hurricane Fiona was the costliest storm ever to hit Canada. We might be looking at potentially breaking that record again if this maintains strength and hits somewhere in Canada here. So this might be something we will definitely have to watch and definitely make comments on next Weather Watch, which if we scroll up to the top, I want to know what time. Yeah, so this is Friday morning, and if we keep going to when we'll be, one more click, this is about what it will look like when we are doing Weather Watch. I mean, we'll have something to talk about next week. for
Right,
sure.
and we can say some things like this, like if this upper trough that kind of migrates across Ontario does not develop to the extent in this forecast,
Yep.
then it doesn't provide the same sort of channeling of the hurricane. And the hurricane may barrel a little further westward into southern New England, so it could be a disaster in Providence Bay.
Yep.
It's going to be really interesting.
Yeah. Great first way to start Weather Watch. Bad first way if you live on the East Coast.
Yeah, and good introduction to Biz 5D next week. It's impossible
Yes.
that we won't look at that.
Yes.
It's impossible that we won't.
Yes.
It's going to be so interesting.
And I'll end now, if we could go to Tropical Tidbits. We'll cut a cross section through Hurricane Lee as it's expected to interact with that trough. So if we could just step forward, so it's sitting,
Friday 12Z or 18Z.
yeah, that's perfect. And if we could cut it somewhere like this. So remember that Hurricane Lee was just a cigar PV centered in the middle of this domain when it was just a hurricane.
Oh, yes.
Now we have an upper level PV feature that, based on this model depiction, extends well into the middle troposphere. You can see the exhaust, as Professor Martin said, of Lee, which is amplifying this feature, making it more anomalously positive, and these two things can mutually amplify. And so the reason I focused on the trough is because we have a trough, Hurricane Lee, when it might not be a hurricane anymore, might be more strong than what is just forecasted because you have this mutual amplification. And it's in fantasy land at this point, but there is a good signal that these two will interact and could make Hurricane Lee a much stronger storm than is even predicted. It's supposed to be a major hurricane hitting eastern United States, maritime Canada. This might make it an even stronger major hurricane interacting with people who live up in the Northeast. And so this will be something we will definitely have to look at and definitely watch.
It's gonna be good.
And I think if we exit out of this and just go one step forward, here, actually, we can just look at this. So Hurricane Lee right now, from this model look, 959 central pressure. If we step forward one time step, we'll see it weakens a little bit, 961, making landfall in Canada. And then one more time step, 958. So this might be a signal that that trough is mutually amplifying Hurricane Lee, maybe extratropical storm Hurricane Lee, and we might see indication of that on the models right now that these two will amplify each other. And let's take just a cross section to end it through this system, something like that. Perfect. So again, it's messier. This system is definitely losing its hurricane-esque PV tower that's extending up from the surface, but you can still see there is an upper level feature that is tied to hurricane mean.
Yeah, and it takes a long time to shed the warm anomaly, which now
Yes.
starts to look partially occluded in the middle troposphere, because it's a
Yes.
little bit wider in scale. It's just so
That's right.
interesting. The vertical motion's probably maximized right where the high PV is, which is
Yep.
not, it's been the case by those in tropics. Now it's being governed by other rules.
Exactly.
Fascinating.
And
Yeah,
it's
this will be
sitting over
great.
land in this case.
Yeah. Oh, boy.
So come to Weather Watch next week.
Yeah. Going to
Let's talk about this. But that's all I had. Are there any questions about what I showed?
All right. Thank you,
Perfect.
Patrick.
Yeah.
Thank you, Pete. Great. Yeah, that's a nice ad for next week.
Go back.
Yeah.
Nice job. That was great.
Yeah.
Thank you, Pete.
Yep.
Helps when there's stuff to talk about.
Yeah.
Well, next week will be a little bit of a struggle. Won't be much to talk about.
Yeah, well, I'm